So welcome students to this 23rd lecture of digital electronics. In last lecture we have discussed all the concepts about basic gates, that is AND gate, OR gate and NOT gate, right? And I left you with a few questions that draw a truth table for 3 input AND OR gate, and how can you construct OR gate using switches. Okay, so here first I'll start with answering this question because only few of you have tried to attempt that. So I can solve this for all of the students, right? So the equation for the OR gate is y equal to A or B or C, right? So I already have explained that this plus sign is not the addition. It is not the addition, it is ORing. You are performing OR operation, right? So when we consider 3 input, then 2 raised to 3, because we are considering 3 inputs, right? 2 because it is binary, right? So 2 raised to 3 is 8. So we will have 8 different combinations for 3 inputs. Okay, and we have already discussed that it starts from 0 to base minus 1. Okay, so that is what I have written in this decimal form. Okay, so I can again write down here this 0 as 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, so these are the input combinations, right? So we have seen for 2 inputs, 0 combination with 0, 0 combination with 1. So by this way also you can try out for this input combinations, right? But the easiest way to remember is number of these inputs. Write down that number from 0 to base minus 1 and then convert its binary equivalent. So you will get the all input combinations. Okay, so what is the logic of OR gate? In the OR gate, if any of the input is 1, then the output is 1. So that is the logic of the OR gate, right? So here, see here, is there any input 1? No, no inputs are 1. That is why output is 0, right? Now in all other combinations, if you see, there is at least one input which has binary 1, right? So this is 1, this is 1. Here there are 2 inputs which are 1, but we are going to see any of the input. So this is also 1, 1, 1, 1 and 1, right? So let me repeat the statement. For OR gate, if any of the input is 1, output is 1. Okay, so this becomes the truth table for 3 input OR gate. 3 input OR gate. Okay, I hope you have understood this. Similarly, you can even go for this 4 input OR gate. If you wish to go, you can try out for that. Okay, so next question I left you with was OR gate using switches. Okay, now here we want to perform this OR operation. In the AND operation, we have seen that the switches were connected in series to each other. Okay, so in series means same current will flow. Okay, so the current flows through this direction from the both switches. So okay, so that is why they are in series, and this we have seen for AND gate, right? But for OR gate, or so as to construct a circuit that will perform OR gate operation, the circuit arrangement is this way. Okay, where these switches are connected in parallel or parallel to each other, right? You can see if this current flows here, this current gets divided into this point and this point. Okay, the point from which the current divides, then we can say that they are in parallel, right? So what is the truth table of this OR gate? 2 input 0 0 0 1 1 0 1 1, right? So if any of the input is 1, output is 1, otherwise output is 0. So let us verify this. Now here in this condition both switches are open, right? So there is no chance of this current flow, and this LED will remain off. So this is verified. Next, so consider this A and this B. A is open and B is closed. Okay, now since this is closed, the current will get this path to flow and our LED will glow, right? LED glows means output is 1. So this is also verified. Okay, in the next part, A is closed and B is open, right? So our current will flow from the switch A to LED and our LED will still glow, so it is 1. In the next part, both the switches are closed, so current can flow through any the switch which would provide the minimum resistance. Okay, the current will flow through that switch and it will glow this LED. Okay, so in the last case also our LED is glowing, means LED is on, right? So this is the circuit using the switches for 2 input OR gate. Now if you have 3 inputs, then you can add this third switch here, right? So this becomes parallel. Okay, so I had purposefully put that question in our assignment, that how the switches are connected in the OR gate. Okay, so they are connected in parallel. Okay, I hope this is clear for you, right? And then I asked you to construct the circuit for this NOT gate also. Now in the NOT gate, when your switch is off, your LED is on. It is opposite. And when your switch is on, your LED is off. It's simply like बटन बंद आहे तरी फॅन चालू आहे, बटन चालू आहे फॅन बंद आहे. NOT gate, right? So how are you supposed to design this circuit? So this is the circuit. Okay, so here plus minus 5 volt DC we have. This is switch, we can say S1, and this is our LED. Okay, now see, switch open means it is off, right? So since this is open circuit, current has no chance to flow through the switch S1, right? So current will flow in this direction and our LED will glow. So switch is off, LED is on. Okay, so this is the case where input is 0, output is 1. Okay, now when I close this switch, okay, one of the students has perfectly mentioned that in her answer, right? So when the switch S is closed, this becomes the closed path, this one. Okay, and since this LED has some resistance and this has very low resistance or no resistance, and you know current always follows low resistance path. So this is a short circuit, we have shorted. Now since there is very low or no current, no resistance, so this this current will flow through this direction, where it will not go to this LED, and hence LED will remain off. So when our switch is on, LED is off, right? So this is how your NOT gate can be constructed with help of switches. Okay, now once we have understood this, we can now go for transistor, because transistor and diode can be operated as switches. Okay, so in the upcoming lectures I will try to to explain this gates with help of transistor and diode, right? I hope that these answers are clear for you. Okay.